Transitional phases like startup and shutdown are the most hazardous periods in a refinery's life cycle. During these times, safety parameters are in flux. Here is a field-tested breakdown of 14 critical risks and their direct solutions. We'll start with the 7 risks of refinery startup. Risk 1. Water hammer from dead legs. Trapped liquid vaporizes when heat is introduced, causing hydraulic shocks that can rupture piping. The solution: mandate physical pre-startup walkdowns and strict drainage protocols for all low-point bleeds. Risk 2. Brittle fracture. Pressurizing light hydrocarbon systems before reaching minimum pressurization temperature can cause metal to shatter. Use warm nitrogen to heat systems above the MPT before introducing liquid pressure while strictly monitoring skin thermocouples. Risk 3. Centrifugal compressor surge. Insufficient flow during startup can violently reverse, destroying bearings and seals. Keep anti-surge valves fully open in manual control and track operating points against the performance curve. Risk 4. Thermal shock in heavy wall vessels. Rapid heating causes differential expansion, leading to fatigue or cracking. Govern heating parameters strictly, capping heat-up rates at 25 degrees Celsius per hour using automated controllers. Risk 5. Oxygen contamination. Introducing fuel gas into a heater that isn't fully purged can create an explosive mixture. Enforce strict nitrogen purging protocols. Analyzer readings must confirm oxygen levels are below 1% before gas introduction. Risk 6. Catalyst defluidization in the FCCU. Poor aeration causes the catalyst bed to slump or block flow entirely. Maintain minimum fluidization velocities and monitor differential pressure to keep the catalyst bed turbulent. Risk 7. Slugging in flare headers. Undrained liquids can extinguish the flare or rain burning hydrocarbons onto the plant. Route startup flows through knockout drums and use automated pump-outs to ensure liquids are separated before reaching the stack. Now we shift to the 7 critical risks of the refinery shutdown phase. Risk 1. Pyrophoric iron sulfide. Scale from sour crude can auto-ignite when exposed to oxygen during maintenance. Keep surfaces wet and use chemical washes like potassium permanganate during steam out to neutralize scale before containment is broken. Risk 2. Vacuum collapse. Failing to open vents after steam out creates a vacuum that can crush a steel vessel. Mechanically lock open large-bore atmospheric vents before terminating the steam supply to ensure safe pressure equalization. Risk 3. Mixing hot oil and water. Trapped water can flash to steam, blowing hot oil out of drains. Circulate oil through coolers and verify it's below 60 degrees Celsius before any draining to open systems. Risk 4. Trapped pressure. Relying on a single valve is dangerous. High-pressure hydrocarbons can repressurize a system if a valve leaks. Always use double block and bleed manifolds and follow up immediately with physical blinding for positive isolation. Risk 5. Amine or caustic solidification. These fluids can crystallize as they cool, completely plugging piping and exchangers. Flush these systems with warm condensate immediately after feed is pulled and maintain steam tracing throughout the process. Risk 6. Catalyst thermal runaway. Losing gas flow while the reactor is hot can cause extreme temperature spikes. Maintain maximum recycle gas flow during cooling and keep the emergency depressurization system armed. Risk 7. Furnace tube coking. Stagnant oil bakes onto hot radiant tubes, permanently reducing heat transfer efficiency. Establish a high-velocity steam purge through heater passes until firebox temperatures drop below the coking threshold. Expert oversight during these transitions is critical. By following these field-tested solutions, we maintain safety and stability. Operate your refinery safely, reliably, and profitably.